Good afternoon, everybody. Thank you so much for coming to BSides San Francisco 2025. I'm here to introduce our final headliner for this particular theater. My name's Nicolina, so afterwards, if you have any questions, let me know. Let's see, Mr. Simon Wijckmans, who actually just moved here 3 weeks ago. Welcome, welcome.
Thank you.
I'm very excited about what he's going to be speaking to, how to pull off a near undetectable DDoS attack, and how to stop it. So please, sir, Slido. If you have questions while the presentation is going on, we use Slido. He generated this QR code for us. Please feel free to type in there. I'll read the questions if we have time, and this gentleman will answer them. So please, sir, we're excited. Take it away.
All right. Well, thank you, everybody, for coming. I have an annoying special request. I have one sales guy who is currently at our booth, and he was supposed to be here to take pictures. But he isn't. So I would like to ask if any one of you can take a nice picture and either email it over to me or tweet it at us or whatever. That would be awesome. My mom would love you. Thank you very much. Well, whatever. Just do it anyway. Thank you. All right. So, hi, everybody. I'm Simon. I'm the founder and CEO of cside. Previously, I used to be at Microsoft, Cloudflare, and Vercel. I don't want to make this to a sales pitch, but it's important to give you some context here. cside is a client-side security company, and client-side security is one of those terms that people are like, oh, what does it mean? Well, we focus on detecting and blocking dependencies that you may have on your website when they misbehave in the browser of a user. And as a result of that, today I'm going to be talking about some pretty significant, really bad attacks that we see, especially a very difficult to detect DDoS type attack. So first things first, what is client-side security? Honestly, think about it this way, and this does sound salesy, but it is pretty important to put it this way. We spend a lot of money on firewalls, and historically we have. It's been going on for like the last 30 years. We spend a lot of money on server-side security tools. I would say half of the floor upstairs is server-side security tools. We also spend a lot of money on endpoint protection for ourselves and for our staff. But can any web developer in here raise their hand that 100% knows how their application behaves in the browser of a user? Exactly. Nobody really knows how their application is behaving in the browser of a user. And guess what? Bad actors know that. They can very easily find ways to execute their attack in a place you're not watching. And this happens all the time because ultimately browsers are just becoming more and more powerful all the time. And more things are browsers, like progressive web apps, or more things that really don't have to run browsers, run browsers. Browsers are everywhere, and we've heard that so many times, it's a bit of a cliche. But us hackers that think about security, there's one specific thing we really love, and it's a world where the specification and the actual implementation, there's a severe gap in the middle. And that is definitely the case with browsers. And the thing with client-side attacks is they are fully dynamic. You can very easily target 1% of users in a specific geography after office hours. That is the whole purpose of a client-side script, that it can be served conditionally. And that is something that is able to exfiltrate a lot of interesting data, but mostly, given this gap between browsers, also allows you to behave differently in specific browsers. So older browsers getting specific scripts, but therefore also using specific vulnerabilities in specific browsers. Just in Q1 this year, and this is the last thing I'll say that sounds marketing-y, we've spotted 300,000 client-side executed attacks, net new ones on websites. So 300,000 unique websites, actually, being more precise. These were attacks that simple malicious redirects, or would try to exfiltrate session tokens of some sort, exfiltrating things like credit card data, injecting malware, crypto mining, you name it. And that is just Q1 this year. And it's not that we're the best company in the world yet. We're a year old, and we are making our detection capabilities better every day, but this is a pretty substantial number. It's not unlikely that one of your websites that you ever worked on in the past, at some point, has one of these. So let's talk about DDoS. I mean, I could ask if everybody here knows what DDoS is, but I'm just going to assume that everybody understands how a DDoS attack happens and what it is. So where do DDoS attacks usually actually come from, right? My experience working at Cloudflare, of course, we learned a lot about this, and we saw a lot of real practices here. Often it's botnets just coming from compromised cloud hardware, right? So trying to find some type of server-side vulnerability that allows them to inject some malicious payload, finding some leaked SSH or whatever, just getting a machine on a cloud. Pretty easy to detect. I'll talk about that in a second. The other method is botnets on IoT devices. Somehow finding a vulnerability in an IoT device or a very cheap Alibaba IoT device that people unknowingly add to their network at home is actually being used for that. That is a very common one as well. And then, of course, malware-injected devices, the most common of them all. Your grandfather downloads something on its laptop, that laptop is DDoSing other things, or there's an exploit in there that can get used for that purpose. So how we protect against that today, and sorry, I have to look at my notes here to make sure I don't miss anything. You can rate limit things, right? And rate limiting has been around for ages. We all know how to do that. But the question is, what do you rate limit on? The IP address, client-side cookie, account ID, some type of value? What you rate limit on really matters. In the world of DDoS, you're usually down to either rate limiting on the IP, on a specific type of fingerprint you can find on layer 3. So the OSI stack is here. Or you can, for instance, rate limit ASNs that you don't often see, right? And so you do some type of pattern matching over what is normal safe traffic for you. You can also just be a little blunt and block IP addresses that you don't want. For instance, there's no reason for AWS IP addresses to be on my website until you find out that there are reasons for AWS IPs to be on your website. That tends to be a very hit or miss way of doing things. Or you can do things like, let's look at the actual packet size, right? So let's say the baseline of an IP packet to my web server is this size. Well, often DDoS attacks are pretty simple. They're empty packets. They're a little smaller, and they're often the same size. So you can do something like that. You can do things like just encryption that was used, or things like client hello fingerprints. But now you're going up the OSI stack higher and higher and higher. And the result, you end up spending more money having to do more expensive compute to figure out whether this is a legitimate request or not. Then finally, something that is kind of the last resort is, I can't figure out what the heck this is. I don't know whether it is a normal request or not. Let's just chuck a CAPTCHA at it and hope that that stops the bad guy. Well, we all know, in the age of AI, you can very easily build bypass tools for CAPTCHAs. So we're going at a pretty fast pace towards a really nasty world where DDoS attacks, the age-old thing that we've suffered for like 30 years on, is back and is even harder to prevent. And there is one specific type of DDoS attack that we have seen numerous times in the wild that I honestly don't even know how to begin figuring out a way to stop it. So let's talk about what makes it hard to detect DDoS attack. So first things first. Let's say I'm a bad actor and I need to build the ultimate DDoS attack. I want to use real human browsers. A normal Chromium browser. Let's just ignore that that could be really expensive and difficult for me to do, right? But let's just, if I could get my hands on a whole bunch of real human browsers, that would be great. Cool. Now, the next thing is, let's find a way, Yeah, so that would basically mean I want to make sure that nobody actually has to install anything on their laptop, right? Because if you get people to install something, then you need to create value. Creating value creates marketing. Marketing costs a lot of time. You need to get a whole bunch of people convinced that they need to download something. Downloading malware, well, in some cases it's easy, but it's a bit of a mess, right? Let's use residential IP addresses as well. Let's try and avoid using something that could very easily be tracked back to a server farm of some sort. I kind of don't want to deal with IoT devices because I know that they're running weird light operating systems that are quite easy to fingerprint, honestly. And let's make sure that that attack happens at a level layer 7 so that whoever is unlucky enough to be the DDoS protection company for this vendor that you're targeting has to spend a lot of money to actually figure out full layer 7 execution post-SSL decryption, whether this is a legitimate thing. So no malware inclusion, as I said, scripts that run without use. Okay, I'm going to jump ahead there. So the answer is, let's just chuck an advert on an ad network, right? This is the thing where client-side security becomes real. If you want to distribute scripts around the world, when people ask me how do the client-side scripts actually end up on my site, well, I can talk about security incidents like injecting it through an NPM package or somebody managing to hijack some marketing tool or whatever, but it's actually way simpler. Ad networks are literally JavaScript distribution networks. Sure, the most reputable ad networks of them all, they have some type of systems in place to prevent unsecure behaviors. They probably have locked down some of the APIs they have access to, but that's far from every one of them. There's a whole industry of secondary ad networks that are not really caring about security. So it's not that hard to distribute a JavaScript across a bunch of browsers. You can also think about, okay, let's find some unpatched server-side CVEs in client-side scripts that already exist. I think many of us have heard of the polyfill attack last year. Somebody just bought a domain name from an organization out of China, quite organized. I can talk about that in detail. They had that domain for 6 months before they pulled off a really visible attack. We don't even have to go there. There's a lot of 20-year-old marketing companies out there from random places in the world that have very severe server-side CVEs that you can just exploit, that have been around for years. Quite scary, but the truth. You can also just, as I said, use an open source dependency, NPM, or you can find, and this is the most easy of them all, it's kind of ridiculous, but yes, S3 buckets do expire, and people do forget to remove them from client-side code. In fact, we have a little tool on our side that when we see one of those S3 buckets, we automatically register it again because we know that it's just a matter of time before somebody does, and we'd rather have it ourselves. So let's assume you've now found a way to put JavaScript in a whole bunch of browsers. Looks like there's plenty of ways to do that, right? Well, I'm going to give you a couple of examples of things we've seen in real life. So this is an iframe flooding method. So it's a hidden iframe. You wouldn't visibly see anything, but it's actually trying to fully render the targeted site, like a normal human would, like a normal browser would. This is not going to look any different from you as a normal human going to a website. Let's jump to another one. So this is just a fetch XHR method. This would be a lot easier to catch because often, well, this wouldn't mean the actual full page is being rendered, right? So you can recognize this is just an opportunistic fetch, right? So this is easier. You could stop this at some level. I mean, at layer 7, you could probably figure out this is not a real browser. You could go the web worker-based flooding route, where you literally just create a backend web worker. And that thing is just fetching away. You can even combine it with that iframe method. And then there you go. You just found another way to use potentially hundreds of thousands of devices in your botnet. And then number 4, this is the window open method, but hidden. So we've all seen tab floods. To be fair, nowadays, Chrome is doing a good job at hiding them often. Don't forget, it's not because it's hidden that it's not working. There are definitely ways to execute this very easily. And there you go. There's now a bunch of tabs that exist that you don't even know that exist. And they are rendering pages. As you can see here, it's basically just fetching the victim's domain. And those are just 4 examples, but there's a few other methods that basically come back to the same concept. So what do these attacks, except for number 2, do? Well, they basically have the ability to bypass pretty much every type of DDoS detection that exists. It's coming from a human device, from a human browser, doing full rendering of a page. How are you going to stop it? I don't know. You can even add a little library there that bypasses potential captchas that are on the pages, right? It's not that hard. It's quite lightweight nowadays even. We've literally just bypassed all of layer 3 anyway by this method. Thing is that I, as a security engineer, if I saw this traffic come in, it would be completely indistinguishable from a normal human. And so the result is, this happens a lot. I did not realize when I started this company how often we were going to see this, but a lot of these DDoS-style scripts are being distributed across ad networks in really heavily obfuscated JavaScript code, looking like normal things, looking like normal ads. Heavily obfuscated, but you can still make sense of what they do. They proxy request to multiple domains. So sometimes they even have a redirect method where they point to an attacker-owned domain with a redirect server at the end. That's a thing. And I mean, of course, ad networks that are on really high traffic websites, unfortunately, we also have to recognize that a really big chunk of the internet is gambling and porn. And so a lot of ad networks that are reputable do not want to be on those. So we are directly driving these really large traffic websites into the hands of ad networks that really just don't care about security, that don't have the revenue to deal with that don't care by design. And this is one of those things. So let's do some quick math, right? Let's say you found a way to get 10,000 active laptops to load your JavaScript. I wouldn't consider that very hard. And let's say you can get each of those browsers do 100 requests a second. Well, now you ended up with 1 million requests a second. You could take down pretty much any medium-sized business very easily. Amplify that, adjust the numbers, and you basically can take down an entire country. That's not that hard. And so that's where we are. What you can do as a site owner, look, I had to think about this because I called it what you can do about it. The thing is you can stop it at the source. That's really, I think, the responsibility of the web. If you have ads on your site, if you have client-side scripts on your site, you should be considering, what am I doing, right? What am I doing to protect myself, protect my customers? It is ultimately my dependency on my site. I am responsible for it, but you're also protecting the rest of the internet. So your responsibility is to think about these scripts. Well, first things first, everybody here probably heard of CSP at some point. It's an absolute headache, isn't it? But it does exist, and there's a reason why it exists. And so at some point, we just got to get real and recognize that even a loose CSP is better than no CSP at all, right? Then we can talk about sub-resource hashing. I think it's a funny concept that that thing is still considered a real solution, because let's face it, a lot of these scripts are just really dynamic nowadays, and SRI does not handle that at all. There is a really brand new specification to our SRI coming. It's in the W3C, a lot of people are talking about it. It also adds a reporting endpoint so that violations are not happening quietly. I don't like that too much, this approach, but you can use it. It's one of the methods that you can use. You can also just really make sure that you're darn sure that the stuff you're using on your site is secure. I've never seen a client-side injection come from Google Analytics, right? I can blame them for how they handle data all day long, sure, but that company has their security together, at least today, right? There's no wood, but I would say knock on wood. Just don't trust some weird-ass script from some small-ass startup or something you read on Reddit that can boost your SEO. You'd be surprised with how many marketeers fall for that. And then the last thing, or actually, just to the previous point, ask yourself the question, what is your process for adding a client-side script, right? Your marketing intern comes to you, asks, hey, can you add this thing to your site? What's the process? What are you doing? Are you just checking it that day to make sure it looks okay? Do you check it every week? Do you check it every month? Do you check it once a year? You can ask yourself that question. Just in general, I think we are not doing a good enough job about understanding the network requests that come from our sessions in browser of users. That is something that I highly encourage people to log. There are various ways to do that as well. So that is a good thing to do. Little drop, we also have a free tier. I don't want to make this a marketing thing, but ultimately you can get rid of a lot of these issues with our free plan. But then on the other side, it's like, okay, let's say you're the target of this type of DDoS attack. I mean, the only real thing here is a CAPTCHA. But as I said, even that doesn't work today. So we have to start thinking about, I think the real way to do it here is stopping it at the source. And that's where we are. My quick final thoughts. Thing is, client-side security has been completely neglected for a very long time. Browsers are super powerful. We see so many things happen all the time. It's crazy how creative you can get with these types of attacks. And we've seen everything from data exfil to crypto mining to literally people using other people's browsers as storage places for fun. They could do that. You got WebAssembly in browsers nowadays. You can do all sorts of funky stuff with that. And it's also very cost effective, of course. Let's say you chuck an ad on a cheap ad network that gets onto 10,000 laptops. And that's going to cost you less than a botnet on the dark web. And it's going to be harder to detect. Equally, you can then use it for anything you like, really. It's really not science fiction. That code that I showed you earlier, it was only really a few lines, and I think any mediocre JavaScript developer could have written that. But just in general, it's time to think about your application. Like, how does it behave in a browser? Does your front-end team know? Pretty pixels, sure. But what else? What are those 2,000 other dependencies that you have in NPM, and do they have the ability to inject something client-side? Well, yes, right? So gatekeep that. And those are my thoughts. Sorry for the dark subject, people. I'd love for people to recognize that this is a really painful thing, but sometimes I come across these attacks and I'm just like, this really should not be a thing, but it is a thing. Anyway, with that, let's go through some Q&A. Thank you.
Wasn't that amazing? Thank you so much. We appreciate you. He's going to actually read his own questions. He's going to filter them out in case he doesn't like your questions, just saying.
It's so far been pretty easy on me. So I'll start with a very small personal one. What makes you want to move to North America versus staying in London? Is there a greater need here? The thing is, at the end of the day, when you are starting an early stage company like myself, I hired people that I worked with before. They were great people, but you cannot build a company from London the way I'm trying to do it now. Here in San Francisco, when you go to the local coffee shop, you will get bitten in the leg by the dog of a company that is able to be $1 million company. Like the dog of the owner of a company that can be $1 million customer for you. Or the CTO of a company who could literally acquire you, right? Or somebody that could really give you advice on how to take your company public. In London, a lot of people like to act like that. They definitely have the aura and the ego, but yeah, they don't have much to talk about, really. So that was my reason to move. I mean, there's a whole bunch of Y Combinator content on why to move to San Francisco. It definitely is a good place to be to scale a company and to do things well. How does IP reputation and threat feeds fit into this? Answer, not at all. These are my mom's and my granddad's and my IP addresses. There is no threat feed that will catch these IP addresses. It's just people on the internet. So unfortunately, not much you can do there. If there was a fingerprint, then of course chucking that on the feed would help a whole bunch of people, right? But there isn't, from what I can tell. So it's hard to distribute knowledge on this. Why do these instead of crypto mine as an attacker? That is a very good question. It depends on what you're trying to do. If you're really angry at a company and they are really well secured, you may be invested in finding a way to DDoS them and thinking, well, this is going to be very hard to stop. Of course, it's really bad and it's illegal and you never should. But sometimes people have those motivations. Mining crypto through ad networks, that is something that a lot of those ad networks do know is a big problem and they have built detection capabilities for. I would say it's actually the easiest one to catch because you can just monitor things like CPU and memory in sandbox environments. And usually these are not that conditional. But yeah, I mean, it's different motivations. DDoSing a company has the aim of taking them down and doing financial harm to them. Crypto mining through client-side scripts in random people's browsers, that's usually not directed at one company. Cool. Then, that made you think, well, it's creative, bad, but kudos. Okay. What's an attack you've seen that made you think, whoa, that's creative, bad, but kudos to you, and why? That's a good one. One we did a blog post about I thought was particularly bad. It was a client-side script that really conditionally, after X amount of seconds of waiting, would pop up a Google-branded, Chrome-branded, you must update your browser window that was completely indistinguishable from the real thing. And when you pressed update, it would download malware. That was one that I was like, well, somebody really took a good course on how to design like Google here. So not that creative. I think this DDoS thing is one of the more creative ones because I didn't think about it when I started this company. I've seen a lot of client-side attacks in my past career, and I mean, usually it's exfiltration of some type of sensitive data or the crypto mining stuff, but DDoS was new to me. I also get why. These scripts didn't look particularly malicious, did they? I mean, it wasn't that they were using specific APIs that make alarm bells go off. But yeah, at the time we didn't see them, so I didn't even know that that was a thing. Will you be at the Seaside After Party? Of course we'll be at Seaside After Party. There's a big party at 221 Main Street. We're co-hosting it with Socket and with a few other companies as well, like Arjet and Instant.io. And also on Wednesday we're doing one for RSA. So let me know. Is mining crypto through cross-site scripting a big threat? I mean, through cross-site scripting here is the word that makes me a little confused, but I mean, there was a high time for this, but as I said, the libraries that were used for crypto mining, because by the way, a lot of client-side attackers are, I would say, a little lazy. They reuse code a lot. A lot of the libraries that do client-side crypto mining are so standardized and easy to detect that they're not really that big of a thing anymore. Don't forget, this client-side space is mostly powered, at least our competitors, not really us, by threat feed intel, right? So RiskIQ and VirusTotal and those types of companies, they will crawl the internet and try and find scripts that do crypto mining. And I wouldn't say they do a great job at it, but it's really a matter of time before this newly registered domain gets scanned by those. And especially with Google acquiring RiskIQ, with VirusTotal, they know how to crawl. They're very efficient at that. So I wouldn't be surprised if there's more advanced detections there. So crypto mining, I think there's always limited lifespans on those attacks. But then to my point, attackers know that. They will just move to a different domain 2 weeks later. And then there you go. And then avoid detection all over again. And we're back at square one. Don't we all love a cat and mouse game? No? It's so interesting. Cool. That was the last question I had. Is there any other questions for me so far? Don't we love that it's like 5 minutes early, last session of the day. We can wrap up our Sunday. Awesome.
I'm so happy he's on time and